Here we're asked to calculate the flux for some given electric fields over some given surfaces. The way to start this problem, of course, is to say the flux is the integral of E dot ds. E is given, so the trick is just to take the surface and draw the ds vector. For the front triangle, the ds vector, ds, will be the size of the little slice times the unit vector ix. We can now do the dot product. E alpha x squared ix dot ix is 1, iy dot ix is 0. So E dot ds will be alpha x squared ds. But we have to be careful. What is x? On that front plate, the value of x is everywhere w. On the back triangle, the value of x is everywhere 0. So the flux through the back for this electric field would be 0. The flux through the front, x would equal w. And what is ds? It's a piece of a triangle, so when we integrate ds, we get the area of the triangle 1/2 the height times the base. The second part asks for the electric flux out of the sloped rectangular surface. Again, the first step should be draw the ds vector. In this case, there's the sloped surface. There is the ds vector. This is the y direction. This was the z direction. Let's write ds in unit vectors so we can take the dot product. ds, if this angle is theta, this angle will be theta, 90 minus theta, back to theta. So the ds vector will be its length times the sine of theta in the iy direction, plus the length of ds, size of ds, times the cosine of theta in the iz direction. Since the electric field doesn't have a z component, E dot ds, just the y component of the electric field times this y component, so this will be beta ds sine theta. Beta and sine theta are constants, so the integral of E dot ds will be beta sine theta ds. What is the sum of all the ds's? The area of that rectangular plate, which is the base, w, times the length, which happens to be the square root of h squared plus l squared. The third part was a bit tricky. The third part said, suppose you had an electric field that varied in a different way. What is the trick? Once again, what's the ds vector? The ds vector will be its length times ix. What will be E dot ds? It will just pick off the x component of the electric field, alpha z squared ds. And now the trick is, what shall we take for ds? We could try taking rectangles. We would have a double integral. The trick would be, take a slice which has a constant value of z. And then what is the area of this tiny slice? The area ds is equal to y times dz. So the integral of E dot ds becomes the integral of alpha z squared y dz. You can't do the integral of y dz unless you know how y depends on z. But this is just a straight line. Just because we're not in the calculus building doesn't mean we can't use the equation for a straight line. Forget about y and z. A straight line, y is equal to mx plus b, the famous slope and intercept equation. Use that to give you y as a function of z, and we're finished with the exam.